Assalamualaikum warahmatullahi taala wabarakatuh. In today's video, we continue on chapter 5 for week 6. Okay. Untuk week 6 kita pergi ke chapter 5 under the topic of fitting other models and continuous data. Okay. So yang ni sebenarnya is continuation from the chapter 4. Okay, but if we cannot use linear line regression or polynomial regression, then we can use other models in order for us to linearize it. Okay, for this one we call it data linearization. Okay, so under this chapter we'll be using this model. There's a few model. If you look at page 64, this is just among the models that we can use. Transcendental model. So in example, there are two examples in here where we'll be using number 4 and number 6. Yeah, so this is the exponential model and this one is power model. Okay, so we'll be using this model. So every single model, they have their own way of linear transformation. So let's see first these two examples on page 65. Okay, so first of all, okay, if you look at example 1 in page 65, this is still under discrete data. Still under discrete data. We use other model for discrete data. So let's say the question asks you to use least square methods to fit exponential model. So it's already given to you what kind of model you need to use. So in this case is exponential model, which is number 6. Number 6 tadi. So you have this y model, y equivalent to ae power of bx. Okay, this one. Okay, so this is the discrete data given to you. You have 1, 2, 4, 6 data. Okay, 6 pair of x and y. So since the question asks you to use exponential model, so we set y equivalent to ae power of bx. Our target is to identify what is the value of a and what is the value of b. Okay, so we need to identify that one. So to linearize it, what you need to do is basically, if you look at what I have written in this red handwritten here, okay, you have this y given y equivalent to ae bx. This is the model, the original model. What you need to do is to ln y and also ln both sides, left and right. So you ln y equivalent to ln, put everything in the bracket, a multiplied by e power of bx. So it applies the rules of ln. So it's multiplication, you can split it into plus like this, ln a plus ln e power of bx. So this one is ln, another property of ln, where we can take this bx, make it into multiplication like this, bx ln e, and ln e is equivalent to 1. So simplified, you should have this ln y equivalent to ln a plus bx. So this is the model that we are going to use. So we try to, if you refer back to this table, our target is to identify our a0, a1, x. So this model, okay, this one. So try to link with our new equation here. So what is your a0? Your a0 is basically this ln a. It's constant. A0 constant, is at the x. So b is your a1. This is your a0. This one will be your a1. Okay. So this is the value that we need to find out. So next is to, on page 66, is to transform that model y. We use capital Y here. Okay, so we let y, the capital Y equivalent to ln y, yang on the left hand side. Okay, so yang ni saya cakap tadi, you got your a0 equivalent to ln a, then your a1 equivalent to b. Okay, this one tadi, yang situ dekat sebelah tadi. Okay, so you got y ln, which is your ln y, equivalent to ln a, which is your a0, plus b is your a1 and x. Okay, next step is basically about the same step as before for discrete data on chapter 4. So you need to create this normal equation matrix. since this one is this is a 2 by 2 matrix. Okay, so we use 2 by 2 matrix for this one. So sama concept dia, you got your n, your summation for xi, x squared, xi squared. Yeah, you're in column for your matrix for a0, a1. Yeah, this is the variable, the coefficient, sorry. So this one is your y. Your y plus, saya silap, sorry. So this is the equation where you have the summation of y, which is ln y. Then this xi with y, capital yi, which is represent again, remember y is your ln y. So next, once you have identified this one, create the table. Okay, create table. So create a table again macam sebelum ni juga. You got your xi first column. Yang ni kita boleh je letak kat sini your y yang given in the table. Kita boleh letak a second line, a second column pun boleh. Yeah, you can use that one. Otherwise, kita tahu we need to calculate x squared. So kita buat sini pun boleh juga x, lepas tu kita cari x squared because we need to find x squared. Lepas tu we have a y from discrete data. Yang ni daripada discrete data given. Okay, yang ni awak kena kira daripada sini. Then we need to identify this y ni. So this column will represent this y besar, which is kita tahu tadi y besar is equal to ln y kecil, ln y. So tekan calculator, ln, ambil y yang ni, y daripada discrete data tadi. So this one is all tekan ln y. So awak dapat ikut yang ni lah. Ini dia letak ln y. So tekan calculator dapat yang ni. All this equation perpuluhan ni lah. 6.6, saya tak nampak pula dah. 6.634, 611 and so on. Nak tekan. Saya just cari sikit je kat sini. So next is your xi, y besar i. So ambil yang sini, first column dengan yang ni darabkan. So you should end up with this one. Lepas tu macam sebelum ni juga, chapter 4, you just sum it up for every column. Dan masukkan dekat bahagian-bahagian yang terlibat. Okay. So you have 44, 63. Okay. Lepas tu, next, either you want to calculate manually using Kramer-Gauss elimination method, or you can just calculate for regression or for or stat number 3. Statistik lah, tengok model calculator, your calculator. Then tekan seperti yang saya bagi contoh sebelum ni. So you should end up with A0 dengan A1. You should identify your A0. Kita tahu tadi A0 is ln A. Ln A dalam equation yang kita dah normalize tadi. Okay. So your A1 is B. So B ni tak ada benda nak buat. So A1 apa-apa nilai, A1 nilai kita punya nilai B yang kita perlu letak kat sini, Bx ni. Cuma ln A, apa yang kita dapat ialah A0 tapi dia sebenarnya equivalent to ln A. So kita kena olah sikit macam ni. Okay. So you can nulis substitute balik. Your A0 equivalent to ln A. So kita need to identify what is A. So exponentialkan lah macam biasa, standard biasa. Ya, exponential kiri, exponential kanan. Ya, kanan. So kita akan dapat ni. So ni ialah E and ln, dia akan dapat 1. Yang A bawa ke depan. So you got your A E ln. E ln upon ln. Okay. So this is equivalent to A. So tekan calculator lah. You should end up with that one. So yang B tak ada benda, just masuk. Sebab tu once you have identified your A0 equivalent to ln A, dah kira dapat A. So this is the value of A. Then sumbat kat sini. Kita punya model asal Y equivalent to A, E, B, X. So A, E, B, value B masukkan kat exponential model tadi. And then that's it. The last part. Okay. So this is if you want to use exponential model. So I'll stop here first. Next we'll go to example 2 where we use another type of model which is number 4. Okay. Okay, assalamualaikum.